Coloring crypto.
Just this week, Ethereum shrugged off a serious security issue with Parity wallets. The SEC started to crack down on bounty programs for initial coin offerings. Munchee Coin, the folks we talked to in episode 7, they paused their ICO. Segwit2x was called off and the price of Bitcoin hit an all-time high. Man, this happens fast. Visit our sponsor, tinycables.com/color. I love Tiny Cables because they don't get tangled. Charging cables that'll change your life and clean up your desk. All right, folks, get out your crayons. We got some coloring to do. Today, Ryan Flint tells us about Kilowatt Hour Coin. According to him, the amount of electricity needed to computer process all of the cryptocurrency that's happening right now could power a small country. That's a lot of electricity, and if the blockchain is to live up to the hype, it's got to be more efficient. Beyond the greed, beyond the get rich quick, beyond the speculation, beyond the hype of the blockchain, there's this huge potential to transform our society. We hear a lot about the transformational potential of the blockchain, but it's hard to find tangible examples. Nothing against that, but it's refreshing to get a guest who's focused on impact. Ryan is working with Kilowatt Hour Coin. Could this be a solution for the crypto energy conundrum? To understand, we start by talking about the hardware required to mine cryptocurrency. Ryan, why don't you start by giving us your background?
I went to Cal Poly for originally environmental engineering, but then I switched to soil science and was involved with environmental technologies. So I took some programming classes in like C++, but mainly studied chemistry and biology and complex system theory. And then about 8 years ago, I moved up to Mendocino County and kind of got into trying to find land and create like a land-based project and live off grid. And about 3 months ago, one of my land partners had a bunch of Ethereum, Ether, and a little bit of Bitcoin, and was talking about what was happening with the price explosion because he bought quite a bit of it early on. And so he was really happy with what was going on with Ethereum. And so it got me pretty intrigued by cryptocurrency. And we were putting in solar panels together and living off grid and started putting the two things together and kind of wondering, as I did more research into Bitcoin, wondering about, the power consumption and how everything had gone to these large processors in, especially like in China, where they have giant warehouses just running, giant chip machines with fans, and kind of got me thinking about all of these kind of things. Kind of what led up to the point where I'm at now, and now I'm working with a team of awesome people from around the world that are working on Kilowatt Hour Coin, and it's kind of like our answer to this energy cryptocurrency conundrum.
When you mentioned these large processors in China and other places around the world, you're referring to the mining.
The mining, that's right, the mining process.
Tell us where the inefficiency is in what's happening now.
Okay, so the conventional thing that creates coins, this started with Bitcoin kind of being the original cryptocurrency. They call it mining because you're creating coins using energy through a proof of work. You're basically creating a puzzle that creates an amount of difficulty. So your computer has to kind of work at it, kind of making it so that originally so that you had to at least contribute some sort of work or effort so that it wasn't super easy for people to just whip up a bunch of Bitcoins. They had to make some sort of qualifier. And it also made it secure as part of the algorithm of all the other computers checking against each other. So it would run extra processes because other computers had to do some extra work too. And so this all was fine when the network was small and wasn't much power, but then people jumped into realizing that GPUs, graphic processor units, could figure out these puzzles better and quicker than CPUs that were just the normal processor inside your home computer. And so people started buying up all these GPUs, which are basically built into graphic cards that gamers were using. And so they started just stacking as many graphic cards as they could fit into a unit and throw a couple extra fans on there. And GPUs use a lot more energy. They give off a lot of heat. They have a lot of fans that need to keep them cool. So that started increasing the power use even more. And it also made graphics cards kind of expensive for gamers. So they were kind of pissed at all these people doing Bitcoin mining. But it's interesting that they use the term mining because it's literally using energy from petroleum. Most of the energy that we're using right now to power these sources are coming from fossil fuel generation plants. And petroleum literally means rock oil, petroleum. So it's literally like we're mining out of the earth this energy source. They went from figuring out that GPUs could do this puzzle process to figuring out ASIC chips. So these chips were specifically designed to run the Bitcoin algorithm and figure out this puzzle. So they could do it even faster than GPUs. And so they started making specialty miner units with these, which was basically a bunch of these ASIC chips and fans, and it just blows through this unit box, cooling off all the chips. It was much more energy efficient, but it was also faster. And so they started stacking these on shelves in big warehouses, consuming way, way, way more power than you would from just a home computer. So the networks kind of at that point went from being really decentralized, being a lot of home users, to these big facilities, which was then kind of counteracted, kind of decentralized a little bit more by people forming mining pools. So people would buy one of these little ASIC chip miners and put it in their house, or maybe buy a couple and run those in their house and calculate how much electricity they would use and make sure that the Bitcoin price was relevant to that. And then they would join pools. So they would all pool their mining computing power together to try to figure out a puzzle and then split the Bitcoins amongst the pool members. They're basically using the amount of energy of a small nation, like I think it's the same as the island of Cyprus. So we've got to this point where Bitcoin mining and there's Ethereum mining and other altcoin mining as well, they're consuming a lot of power to solve a puzzle that is now unnecessary. So a couple of them have switched from proof of work, which is this very work demanding mining, to proof of stake or minting. And so eventually all these coins they can't go to infinity. Coins that don't have a stop point, they don't have like a max number of coins that will be created, don't have much value. And so like Bitcoin and Ethereum will eventually one day stop making coins. So people won't be conventionally mining. They'll end up having what's now referred to as like nodal networks. And people are figuring out even more efficient algorithms and more efficient proofs, like the new Faircoin proof is proof of cooperation. And so it uses little tiny Raspberry Pi computers for the nodes. And those nodal networks basically get like an interest or a fee for being a node. And so you make like you're still paid, you're still incentivized to be a node in the bigger cryptocurrency network, but you're not solving huge puzzles and competing against all the other people in the network.
Let me review this sort of brief history you just gave us of the mining process. The original Bitcoin algorithm, they made that original algorithm sort of make the computer work almost in a way that didn't need to be done to write the ledger, but just to kind of prove that it was working on something that would take some time. So kind of like there's no answer in that puzzle that does anything but just kind of like prove effort.
Yeah.
And then they realized graphics chips for gamers, the GPUs were faster, so people started using those. And then somebody actually developed a chip that ran the algorithm fastest, the ASIC chip. And was that just the Bitcoin algorithm, or is that for any kind of like blockchain?
It's mainly the blockchain for Bitcoin, but Bitcoin has a lot of forks and it has a lot of altcoins that were based off of the Bitcoin algorithm. But when you look into altcoins like Kryptonite, which is spelled like NIGHT, they made some that are ASIC proof, or they made them so you purposely couldn't mine with ASIC chips. Or there's some that even have made it so you can't mine with GPUs to kind of push the mining back to more decentralized home computing.
Let's say Satoshi Nakamoto is a real guy who wrote that algorithm. If he could have seen 10 years into the future and seen what would happen with mining, do you think he would have written the algorithm differently?
Yeah, wow, that's a big what if. Yeah, I mean, I would like to think that if it is a real person, that they would have kind of wanted to keep it decentralized, wanted to keep it home computing based. And yeah, it's been really hard to foresee the whole expansion all the way up into ASIC chips. Yeah, I think that they would have hopefully put something in there to have stopped that expansion.
Essentially, this move to proof of stake, if I understand, this might be too simplified, but the difference between proof of work, which is what is sort of the original classic method that you've described the history of there, this move to proof of stake for some coins doesn't require solving some sort of incidental puzzle. It's just based on how much cryptocurrency of that particular coin I have in my wallet.
That's it. Yeah, exactly. It's trying to get more of like a distributed consensus, and so it's exactly using that. It's like how much stake you have in the network. Basically, that's why it's called proof of stake. So it's like how many coins you have in your wallet. So you're probably a little more trusted because you have a little more stake in the system. But then you can see where this might go horribly wrong, where somebody who has a lot of stake in the system wants to mess with the system and has the power to do that.
What are the best examples of coins based on proof of stake where it's gotten dangerous because of a single person being able to kind of wield too much power?
I know. I think there's been more critiques. There's been actual critiques of what could go wrong than things that actually have. More the things that have gone wrong with proof of stake algorithms have been where basically they create a bunch of altcoins or different spin-off coins from Ethereum. They're using the Ethereum ETHASH, ETHASH, like instead of hash, it's the Ethereum hash protocol. And they didn't secure the wallets properly. There was a problem. Hackers came in, and they started emptying out the largest accounts first. So they had checked the blockchain, they had seen which accounts had the most coinage in them, or they knew they had accounts with large amounts of coin. They used this glitch in the matrix, just started emptying accounts out. And then luckily someone in the network noticed and then wrote the code in really quickly to stop it. But it was like this huge weakness that was exploited more because of the popularity of proof of stake and people not really checking their code and just kind of building their own coins off of it. Where I think Ethereum itself, because they were the first ones to really launch this and become popular with it, have, built in way more security. It's hard to say because both Bitcoin and Ethereum are kind of like top-down structures. It's like whatever the designers at the top want to do, that's what's going to happen with the coin.
Right. Okay. There's a lot of, I've got questions on lots of these things you just mentioned, but I really do want to make sure we have time to get in deep with the solar project you're working on. So maybe starting with this problem that you kind of addressed of this centralization of all these computers around the world that are mining, they're creating lots of heat, lots of wasted energy, and you've had some involvement with solar. Can you kind of draw that bridge for us?
Yeah, the whole solar thing came up when I was thinking about this, living off grid, and we're basically living off of solar. I realized that the solar controller units have built-in data loggers, so it's really easy to kind of keep track of the electrons that are coming out of your solar panels. And I also have been into Raspberry Pi devices. and the little hardware adaptions that you can put on them pretty simply to make them into like little simple controller units and nodes. And so I thought, why not link these together? Why not take and basically calculate how much solar you're using and put that into its own blockchain? There's already a few companies. There's people doing like green coin, and there's some like alternative energy, like biofuel, like a big giant bio waste heat fuel plant. They basically like burn a bunch of wood chips or agricultural wastes and create steam up in Canada, created their own coin. So I started seeing all these different kind of attempts at it, and then I found Solar Coin, which is a coin that's run by Solar Coin Foundation. And they were kind of the first entrepreneurs into this. And so they made it super easy to do it. They had like a pre-mined amount of coins that they set aside, and they said, we're going to have this many coins to calculate to incentivize this many megawatt hours of solar power creation. So you basically take a picture of your solar panels or the back of the solar panel that has the energy rating on it, and your solar array, you send in like the whole, proof of purchase thing from the installer, and you send it into Solar Coin Foundation, and then they give you X amount of solar coins calculated off of like the efficiency of your panels. So they kind of downrate however many the exact megawatts or kilowatt hours of your panels are, and then they give you that much coin per year.
Even before laying out those issues, so what's the benefit to me if I have a solar array of sending them, my energy rating, proof of purchase, and they get me solar coins? What do I do with that?
You can technically exchange that on exchange for what, like if you're purchasing things in US dollars, you can exchange Solar Coin on, I think Bittrex has their exchange right now.
And is this somehow solving the issue we brought up of the inefficiencies in the mining, or how is this? I'm not seeing the correlation here, the exact.
No, so this one isn't. If you're gonna quote unquote solve the efficiency problem with Bitcoin, either Bitcoin miners themselves have to solarize their Bitcoin mining operations. They would have to switch over themselves to switch that network out. Or you, like Buckminster Fuller said, you create a better system that everybody goes to that basically replaces the old system because it's better and more efficient. And so Solar Coin is kind of the in-between transition phase. It's kind of incentivizing people installing solar panels and getting something for it, but they didn't decentralize it. So it's this foundation that kind of issues the coin. You send in a paper. It's very kind of like hands-on. A person reads the thing and issues the coin. It's not generated by a computer through a data logger off of your solar array.
Okay.
So it's not like accounting real time for how much solar is actually being created, and the coin isn't worth enough. It's like insignificant right now.
Okay, so Solar Coin is really just getting your validation that, hey, you're part of this greater vision. Here's here's a few coins, not really worth very much, but it's sort of positive validation just for becoming part of this network. But there's no real kind of like loop or reading of the amount of power that you're generating.
Right.
Okay.
And they're, and it's nice because you're, like any of these Bitcoin startup operations, when you get in early, sometimes it pays to get in early while the coin is cheap and it could go up significantly.
Right.
Who they're working with though, and there's a lot of parallels with, is Electric Chain. And Electric Chain is their R&D wing, and they're their own separate thing. They're willing to work with any other blockchain. They don't have to work with just Solar Coin, but that's who they're working with right now. And they're developing really awesome projects with like microgrids and one person using electricity in one house basically is peer-to-peer paying the person who's producing electricity from their solar panel, or the person charging the microgrid battery in the center of town is getting paid for the kilowatt hours of electricity that they're feeding into the battery bank. a megawatt hour is a lot of electricity to get one coin. So that's why we chose Kilowatt Hour Coin, because that's much more reasonable. That's more like home rooftop scale.
Is the electric chain just sort of a semantic thing? Like they're just sort of rebranding the idea of using, the blockchain for power? Is it literally a new blockchain, or is it just a new name?
It's just a new name. It's a play on words from electricity and blockchain. I think a little hybrid.
Okay, so this is the research you did. You checked out what SolarCoin was doing. You found out what they're doing with electric chain, and then this moves to what I think is your own project, Kilowatt Hour Coin.
Yeah, it's actually interesting because when I came to this, I think I posted something about the concept. I hadn't called it Kilowatt Hour Coin. I had put in my original paper that a kilowatt hour is what it should be based off of how much rooftop solar is produced. And then a couple people hit me up and said, hey, we're actually starting a project called Kilowatt Hour Coin. And it was a gentleman from San Jose, California. And he messaged me and he invited me to the Slack group. And so I saw there was kind of like a small group of people that already had the concept in mind, but kind of had no idea how it was going to be created or how we're going to like start the project or like what's our go-to point. They just were kind of have the same idea. We're interested in like jumping in on this ICO market, which kind of everybody wanted to recently.
Cool.
And knew that it was going to catch. They knew it was going to be a catchy thing. So I came in and said, became basically lead designer and said, well, here's the vision. Here's where I think we should go with it. And then this is what we should do to launch it.
Very cool. So you found like-minded folks, and you guys are all moving ahead together on this. Maybe give us the basically what it is, how it works.
Okay, so what we've decided to do is create this hardware device, basically a kilowatt hour coin meter. And so it's going to interface with smart meters. If you've already got that on your house and you're already got like a grid tie solar system that's feeding back into the grid or vice versa, or people, which is more rare, that have microgrids that they're connected to. And we're going to create like a simple meter that goes on-grid or off-grid systems that plugs right into your controller, or will possibly replace your controller if you're putting in a whole new system. And it just creates kilowatt hour coins in a secure transaction, because we realize you have to kind of incentivize this somehow. You have to put this out there. And so we're going to try to create a loan program, so that this meter comes with solar panels that fit to whatever size unit you have, whatever house and whatever available space you have for solar. Our controller will pair with that, and we give that out on a loan, and it pays itself back in generating cryptocurrency. And so when the device has paid itself back, it becomes the owner's device and starts paying them in cryptocurrency.
Say that part again, but just with some examples. So
okay, here, I'll give you a real world existing example. In Africa right now, they have a loan program for solar panel, like off-grid little home battery solar generator set up with like lights, like little LED lights you can plug in, to replace the kerosene lanterns and the purchasing of kerosene from town. So this company built a bunch of these, and they loan them out to the villagers, and they say, okay, instead of like, how much were you buying in kerosene every week? Okay, instead of going to the kerosene guy, you give me that money and slowly, like micro loan style, pay back the solar generator.
Okay, apply that now to Kilowatt Hour Coin. How would it work?
So you pull up in your electric car to your house,
okay, and
you plug it into your house to charge, and you go in your house and you put in like your Shift cryptocurrency card into the little adapter slot in your computer, and you open up your wallet, and you look, and your solar panels charging into your battery bank, into your electric car, are tallying up kilowatt hour coins into your wallet. And so you're getting paid to charge your car from solar. Or if you have a battery bank that it charges into, that feeds into a little microgrid that feeds the rest of the houses around you, then as it's building up, it's tacking money into your wallet. And then you can go out and, unplug it and go out there and spend your coins on your Shift Card wallet, because it'll automatically exchange it into US dollars.
Explain for our listeners Shift Card.
So Shift Card is like one of the first Visa card, or maybe it's MasterCard, but probably both at this point. But it's just a credit card, like a debit card. And it links into whatever exchange or online wallet you use. Like, for example, Coinbase, that's a pretty popular one. And you basically can set it up to automatically exchange when you swipe the card. Before you go out and purchase something, or you're going to go out and use your card, you can load up your US dollar account from your Ether, your Bitcoin, or whatever altcoin is on your exchange. And you can go out to like Home Depot and swipe and buy stuff, like real stuff, with a credit card.
Okay, got it. So all you're literally doing is just flipping a little switch on your exchange to turn your crypto into US dollars, and then the Shift Card is basically just using those US dollars, but it's linked to that account. So it feels like it's very much like using cryptocurrency with a credit card.
Exactly.
What do you think is would be the most common if kilowatt hour coins take off as a concept and people start using them? Like in the example you shared, I'm imagining, it was me having my own solar panels at my house and me charging my car. But I imagine if this is really happening, this is really much more dynamic, where people could set up, a sort of mom and pop's charging spot at their garage and use their solar panels, and then they could be making kilowatt hour coins off of both selling and buying. It's just a tricky concept to get my head around, where I'm earning coins for producing it and for using it.
You're charging a battery, basically, and that's storing the charge that then gets used. And so you're kind of still paying to use electricity. You're still going to have to, like, if you're not producing your own electricity, and then that's of electricity that you personally use all the time, then you're still going to buy electricity. But instead of buying it from an energy company, you're going to be buying it from your neighbors. And so Kilowatt Hour Coin is acting as the medium of exchange between that, like the peer-to-peer exchange system.
So it's no longer doing any proof of work algorithms, but is it doing proof of stake, or how does that concept apply?
No, so that's what we get to decide in design phase right now. I really like what Faircoin is doing with proof of cooperation, because you can use small Raspberry Pi devices for the nodes, and that makes it really simple.
Can you explain that?
It's a really like small.
Explain.
Yeah.
I mean, Raspberry Pi is the tiny little computer. What do you mean by you turning that into the nodes?
So a node in this other concept, you basically have a network of a bunch of nodes, kind of like the original concept of the internet. Of you have all these little points, and they kind of create like this self-healing system. I mean, the internet itself has become a little decentralized with fiber optic cables and central hubs of servers. But it's more of like a small little server, but it's like a checkpoint. Instead of kind of like competing for a puzzle, it's like a roundabout. It does like a little round robin session, and each node gets a turn doing a transaction and getting it paid a fee for each transaction. So every time someone like you and I want to exchange a Faircoin, the computers have to think, and they have to do a little bit of puzzle work on just recording the transaction. Not really a puzzle, but they spend a little energy and time and computing power recording the transaction that we're going to make.
Okay.
And then another computer has to check. It has to be written into all of the blockchains on all the nodes. So all the other computers have to check too. But what node gets paid for that normally would be figured out in proof of stake or proof of work with whoever competes to figure it out the fastest, whoever's computer wins, right? But in proof of cooperation, each one gets a turn. So it just goes around the nodal network, and each node will get a turn processing the transaction if they're capable. Like, it sets a couple parameters, so that it doesn't, like, if like one of the nodes is acting up or something like that, it's not going to let it do it.
So currently the computers out there that are mining Bitcoin, they may get to working on a puzzle and not complete it in time, and some other computer somewhere completes that puzzle, and the one that didn't complete it gets paid nothing.
Yep. The whole pool thing is, like, it's more likely if you join a pool with more people that your pool is going to win. You may receive less money personally, but you're more likely to solve the puzzle more often.
Proof of cooperation, would that solve the problem of, all this sort of heat being lost by all the computers running the mining?
Well, growth rate piles are pretty small. They don't produce a lot of heat, but still any processing will produce heat. And so Electric Chain also has another side project where they're doing co-heating, where they have all these computers in like a server room in a node, and it directs the heat to like either a heat battery where it's like stored in like a big thermal mass, and then there's a heat exchanger basically in the thermal mass that can be used for home heating. And so they're just moving it directly, and like if it's in the wintertime, they're basically blowing the heat into the central heat unit and heating houses.
You're literally in this group with a team of people working on Kilowatt Hour Coin and looking at issues like what type, do you do proof of stake, proof of cooperation? What's it like? Like, what are some of the sort of really interesting or exciting things for you?
What's really intriguing to me and what really excites me is just being able to like figure all this stuff out and design it, like figure out some of the flaws in everything else and work around those, but also see what the good points are in a lot of these coins, because I'm not trying to throw the baby out with the bathwater. It's like there's a lot of amazing things. Like the whole point of Bitcoin from the beginning was to create like a decentralized banking system. That's amazing, like that they accomplished what they did and that it's so multinational. But part of this creation process has led me into a lot of the open source world and open source programming and software. And I've always been a big fan of run Linux for, I don't know, probably a decade now. But the open source blockchains are kind of what led me to discover proof of cooperation and Faircoin. What really led me in that direction was Steemit community. It's really like this neat, like, it's got this very community feel to it, like very tribe kind of feel to Steemit. And there's a lot of support and not a lot of trolling. And it's just got this really like awesome, like cooperative vibe to it. And that runs on the Graphenene ecosystem, the Graphenene blockchain, which is part of EOS and Dan Larimer's project and bitshares. And I just think it's neat because bitshares isn't trying to keep increasing value like crazy. They're trying to actually create a stable coin. They're trying to create something that is open source and also creates a very stable price. So people feel more comfortable using it as an exchange medium for what it's actually supposed to be used for. Because right now, Bitcoin and all these other altcoins that go up in price and a little bit down in price, but keep going up in price, or even ones that fluctuate, are kind of being used as like a stock market right now. They're kind of like a stock market tool. So that can,
create this instability that makes people not want to trade or exchange it. Like, I don't know if I want to give you a Bitcoin today because tomorrow it could be worth a lot more. So maybe I want to hold on to that. So I think it's neat these open source cryptocurrencies and blockchains are kind of trying to create stability so that people will use it for exchange.
Do you know, in this case, how they're trying to make it stable? Like, are they pinning it to the US dollar? Like, how do you make a coin stable? They're inherently, it's a currency, so it's going to be volatile.
Right. So it's part of their new strategy for a DEX, decentralized exchange. So bitshares has their own decentralized exchange built in where there's no kind of like stock market exchange.
God, that whole last few minutes, so you mentioned Steemit. I think I'd seen Steemit. I hadn't really signed up for an account until just recently. And to me, it looks like, oh, this looks like Medium, but if you get upvoted, you get paid. And I had no idea it was actually built on top of any kind of altcoin or blockchain.
Yeah, Steemit's really interesting. One of the reasons we're looking at the graphene blockchain, or the graphene ecosystem, as they call it, because there's a big bunch of different groups kind of linked into it, is because Steemit pioneered this microtransaction. Basically, they realized that the transaction rate for Bitcoin and for Ethereum was too slow, that it wouldn't account for people liking things, because, you know, you could just get something that goes viral and you're bam, 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 bam. And so you need like a bunch of transactions really quickly to account for that. So they created this whole new open source blockchain called Graphene and based Steemit on that. But Steemit's this really neat kind of media interface. It's almost a replacement for Facebook. It's got some things that I think people really enjoy about Facebook that it doesn't have built into it, and you really need to actually have a bunch of your friends want to come over and post. But it doesn't really put things on a wall for you automatically as well as Facebook would. But that kind of creates more of like you have to actually go and look, and you have to kind of seek out, you have to type in like kind of what you're looking for instead of it being fed to you, instead of it being kind of like TV.
I was just going to add a quick comment on Facebook. I mean, I think a lot of people, if you could show them a better alternative to Facebook, they would be delighted.
I actually have been doing like a little experiment to see if Facebook is building any kind of like algorithm resistance to Steemit, because I noticed that like about 3 or 4 months ago, when Steemit was kind of not really known or unheard of, there's some really good articles that popped up on Facebook, and they went kind of viral. Like there's one kind of calling out like fake spirituality, and it kind of got big. But then I noticed that at a certain point they kind of started like not really hyping up Steemit articles. I noticed that it wouldn't get a lot of hits anymore, or like things I would post the same thing on Facebook, it would get a lot of hits, and then I would basically create a Steemit article mimicking it, and then just post the link to Steemit. It would kind of get less hits, like significantly less.
That's funny.
So
how would you put Steemit into the context of, you kind of just did with Facebook, but also social networking tools or social media tools like Twitter and Reddit?
I think it's somewhere in there like Reddit, but it has less group function. So there's no real groups you join. It's more of like Twitter, I guess, but with longer saved, more in-depth articles. So it's kind of trying to be like a blog site that you get paid for your blogs, but it's also trying to be more of like a media tool where you link with other people.
We're going to have extensive show notes and the things you've covered in this conversation. And I think it's a really exciting time to be picking your brain as you're coming up with some of the solutions around Kilowatt Hour Coin with the team you're working with. Here's an idea. Let's have you back on in a month or two when you might have had, maybe a milestone with Kilowatt Hour Coin. And at that time, what questions should I ask you then?
Ooh, wow. Good question. You should definitely ask how far along we've come with creating a hardware meter and what we've come up with for our loan program. We might try to work with like Waves platform with the Waves tokens and do some sort of ICO incentivization program, kind of like a Kickstarter for these solar generator kilowatt hour meters.
Interesting. And so your first two questions were more about hardware, and you didn't mention, coming up with like the proof of cooperation model. What are the just as we kind of close here? What are the things you found challenging or surprising, or not what you thought they would be, as you've been kind of figuring out what to do with Kilowatt Hour Coin?
Oh, that's a good question. Really getting a good team of programmers together has been kind of the challenge, like getting them motivated on a brand new project with a brand new concept. It's kind of tough just because just the channels and the amount of kind of perception out there on this topic. I think people are so focused on big projects that are kind of out there in everybody's face that it's been hard to kind of pull a lot of people in quickly. Also, to answer your previous kind of comment about why I didn't mention catching up on the blockchain that we're using, is I think at this point we might just create our own. And so I don't really want to fantasize too much about that right now.
Where do people go to get updates and find out more?
So you can go to kilowatthourcoin.com, which is KWHcoin.com. And we're all over all the other media channels. You can find us at, LinkedIn and on Facebook, Steemit, Reddit. What else is there? Soon, I don't think we have anything on GitHub yet, but that's where we're going to be publishing our white paper on our blockchain. You can check out our white paper just on the design concept, and that's on our webpage. And we also have a Slack group, so if you really want to join in and you actually want to get into the development team and stuff like that, we're going to be basically finalizing all that by November 15th. So find us and we'll send you the Slack invite.
November 15th is coming up. We're recording this the last week of October. So yeah, two more weeks here, folks. Well, Ryan, thank you so much. It's been great getting this sort of educational download from you. I hope that this all continues to go well, and I'll definitely want to keep some tabs on this.
Yeah, thank you very much. And you've been awesome, Gabe. I love all the questions, and it's been wonderful.
And I can't wait to replay your questions for you in a couple months, and then we'll do this again.
Awesome.
Thanks a lot, Ryan. Take care.
Thank you. Okay, be well.
Coloring Crypto is now a weekly podcast, releasing new episodes every Sunday for newbies who are curious and experts who think they understand. Tweet us at Coloring Crypto and leave us a review on iTunes.
Coloring Crypto. Subscribe now.